Hey everybody, the purpose of this video is to get you some solutions for the central tendency quiz that involves the river question and the IQ question. The first one, can you cross a river safely if you know the average depth is 2 feet? You can ignore things like flow, ignore CFS and things like that, just talk about depth. So imagine if you can't swim, or even if you could swim but you were afraid of getting into deep water in a river, why an average of 2 feet might be misleading. Well, the point being is that, you know, if you have an average depth of 2 feet, that doesn't mean that it's 2 feet uniformly across the entire thing. That's one way it could have an average depth of 2 feet. You know, for example, in a canal, where a canal is actually made to be a certain depth all the way across. But rivers don't tend to do that. If you've ever fished at Sawyer Park, you know this. If you're going to fly fishing down there where you're in the water, you could be standing, you know, on a boulder and you're fishing along and water's up to your knee and you take one step and you bury yourself in 8 feet of water. On average, the depth of that river might be 3 feet, but that means you've got, you know, 5 sections of 1 foot depth followed by a section of 7. So that doesn't guarantee anything about an average depth of 2 feet being safe. So that's the big idea, is that there might be a very deep section, but it still averages out to 2. So you got to be careful. Sometimes you want to use a min value or a max value versus an average. Not often. I mean, you don't want to, for example, brag about your maximum crop that your backyard garden in Central Oregon yielded, if that's a misleading quantity. But in this case, something like safety, I think you do, or a worst case scenario. Engineers often build bridges using probability. They have a range, confidence limits they call them, upper and lower confidence limits, LCLs and UCLs. And they'll build the bridges, or they'll build a very, very large structure so it can withstand the upper confidence limit of stress. The idea being that's the 95 or 97th percentile on the amount of stress that that object is expected to encounter. If you ever walk in an elevator and you look up at the sign, it says maximum capacity 12 persons or 1,200 pounds, or I wouldn't say that, 2 tons or 12 persons or something like that. They've built the elevator not for the average load, but for the maximum load. So there are certain times when you actually want to use the max versus an average. And part of life is figuring out how to be the most clear and also careful and safe, I guess. Next question. Paul Anthony Samuelson, he said, I was a physics major before an econ major. When I switched from physics to economics, I raised the average IQ of both physicists and economists. How is this possible? So what you want to think about is think about IQ on a horizontal scale, and we'll do the physicists in red, and we'll do the economists in green. So, and we'll do Samuelson in the orange. I think he has 2 S's, doesn't he? So, here's the takeaway. The only way that by leaving a data set you can raise the average is if you were the lowest possible value in that data set. Or if, I shouldn't say that, if you were on the low end, if you were below average already. If your data point was below average, removing you from the data set will then raise the average of the overall. This is the whole concept behind throwing away your lowest quiz grade in a classroom setting. So the physicists' IQs, I'm just going to make up a distribution here. We'll do a quick little dot plot. Okay, we'll make it bell-shaped, or roughly bell-shaped, even though you've got no justification of calling it that. And we'll put Samuelson right here. Okay? So you could tell that if you were trying to balance this tray on one finger, him being the lowest data point, the average has to move to him. If you take him out of that, the average is going to have to shift back to here, because essentially you've removed some weight on this side of the tray, which hopefully makes perfect sense. The economists in green are going to be down this side. And again, I'm just making up a distribution. I have no idea if this is even close to correct. So before Samuelson was an econ major, he was a physics major, so the average of the econ majors were down here, and then when you add him above average, the average is going to shift this tiniest little bit. An average is always going to move towards whichever side the new data point appears. So if a data point appears above average, it's going to move that way. If it appears below average, it's going to move that way. Even a little bit, but that's what his point is that he was at the low end of the physicists, the high end of the economists, and therefore by removing physicists, he raised the IQ there. By creating a new high data point on the economists' scale, he raised the IQ there too. So pretty clever, and glad a guy like that got the Nobel Prize. Hope that helped.